Hello, my name is Fatih Furkan Akic, and in this video I will do a Lab 3.5 machine learning pipeline with Amazon SageMaker. In this lab we will deploy a trained model and perform a prediction against model. We will then delete the endpoint and perform a batch transform on the test dataset. The model is created for us in the notebook as part of the setup. So let's start the lab, and after completing this lab we will be able to deploy a machine learning model, use the test and dataset to perform a batch transformation with the model. So now let's continue, and let's go AWS. So let's go to the SageMaker and let's open notebook instance and my notebook. Let's open in Jupyter. Let's open machine learning and introduction to business scenario. We will work for a healthcare provider and want to improve the detection of abnormalities in orthopedic patients. And we are tasked with solving this problem by using machine learning. We have access to a dataset that contains 6 biomechanical features and targets and normal and abnormal. We can use this dataset to train an ML model to predict if a patient will have an abnormality. And about this dataset, built by Henrik Damota during medical residence period in the group of applied research in orthopedics of the Centre Medico Chirurgical this center Lyon, France. The data has been organized into different but related classification tasks. The first task consists in classifying patient as belong to one of 3 categories: normal, dyskernia, and spondylolithiasis, and attribute information. Each patient is represented in the dataset by 6 biomechanical attributes that are derived from the shape and orientation of the pelvis and lumbar spine, pelvic incidence, pelvic tilt, lumbar lordosis angle, sacral slope, pelvic radius, grade of spondylosis. The following convention is used for the class labels: DH, SL, NO, and AB. For more information about this dataset, we could go this link, and in lab setup, because the solution is split across several labs in the module, you run the following SAS that you can load the data and train the model to be deployed. And the setup can take up to 5 minutes to complete. Importing the data will import the data by running the following cells, and let's run it. Let's run this too. So we will wait a bit to print ready for hosting. So let me pause the video and I will continue when it's ready. So it's ready for hosting. And step 1, hosting the model. Now that we have trained the model, we can host it by using SageMaker hosting service. The first step is to deploy the model, because we have a model object XGB model. We can use the deploy method for this lab. We will use single ml m4x large instance. Let's run this cell. So it's creating model with name SageMaker XGhost and creating endpoint config and endpoint. So let me pause the video again and I will continue. Now it's ready. The step to performing predictions. Now that we have deployed the model, we will run some predictions. First, revive the test data and refamiliarize ourselves with it. So test shape, we have 31 instances with 7 attributes. The first 5 instances are these. We don't need to include a target value. This predictor can take data in the comma separated values CSV format. We can thus get the first row without the class column by using the following code. Test.ilog the ilog function takes parameters of rows, comma calls. To only get the first row, use 0, 0, 1. If you want to get 2 rows, you could use 1 and 2. To get all columns except the first column, call 0. Use 1 to open. So let's run it. We can convert this to a comma separated values file, CSV file, and store it in a string buffer like that. As you can see, 88.02449 like that. So as you can see, so now we can use the data to perform a prediction. So let's run this cell. The result we get isn't a 0 or 1. Instead, we get probability score 0.9.66071 and goes like that. We can apply some conditional logic to probability score to determine if the answer should be presented as 0 or 1. We will work with this process when we do batch predictions. So we uh, we can apply some conditional logic to make a threshold. So for now, compared to result with the test data, is the prediction accurate? The question and challenge task: update the previous code to send the second row of the dataset. Are those predictions correct? Try this task with few other rows. It can be tedious to send these rows one at a time. You could write a function to submit these values in a batch, but SageMaker already has a batch capability. We'll examine that feature next. However, before we do, we will terminate the model. So let's run this cell like that, and let's convert it and predict them. So let's run this too, and we can change the ilog code as we like and try the other values from the dataset. So we can do it, but let's leave it as it is. Run these codes again. So in step 3, terminating the deployed model, to delete the endpoint, use delete endpoint function on the predictor. Rerun it. So deleting endpoint config and deleting on endpoint we created. So performing a batch transform. When we are in the training, testing, feature engineering cycle, we want to test our holdout or test sets against the model. We can use those results to calculate metrics. We could deploy an endpoint as we did earlier, but then we must remember to delete the endpoint. However, there is a more efficient way. We can use transformer method of the model to get transformer object. We can then use the transform method of this object to perform a prediction on the entire test dataset. SageMaker will spin up an instance with the model, perform a prediction on all input values, write those values to Amazon S3 services, Amazon Service S3. Finally, terminate the instance. We'll start by turning our data into a CSV file that the transformer object can take as an input. This time we will use ilog to get all these rows and all the columns except the first column in here. Next, write our data to a CSV file. And last, before we perform transform, configure our transformer with the input file, output location, and instance type. In here, as we can see, input location and input location, output location, and transformer code. Instance type ML and for X large. And let's run it. So I'm gonna pause the video and then I will continue when it's finished. So let's continue. After the transform completes, we can download the results from Amazon S3 and compare them with the input. First, download the output from Amazon S3 and load it into Pandas data frame. Let's run this up. We can use function to convert the probability into either 0 or 1. The first table output will be predicted values, and the second table output is the original test data. We define a binary convert, and as I said, define a threshold, and if x greater than threshold, return 1, else return 0. Target predicted binary, target predicted class, apply binary convert. As we can see, we convert them. Note the threshold in the binary convert function is set to 0.65. Experiment with changing the value of the threshold does impact the results. The initial model might be not good. We will generate some metrics in next lab before we tune the model in the final lab. So let's change the threshold value. Maybe we can do it 0.7080. So as we can see, if we do this, this should be and this should be return 0. So as we can see, it impacts the results. So this is the end of this lab. Thank you for watching. Have a nice day. See you later.